has 33 years of industry experience in the gas and electricity sector, and 22 of them as a professional engineer. He's a fellow of the ANZ, member of the EEA, Ziegler, and Institute of Directors. He has worked with regulators, government bodies, treasury, and international organizations such as the IEA to provide expert evidence, sector experience, or government oversight. Developing alternative systems and approaches to network and business issues has Andrew working in the grid development part of Transpower. Andrew's involvement with robots and their application in the electricity system started in 2012 and includes both line and substation applications from a practical and business perspective. Andrew was a contributing author to the Ziegler technical brochure on the application of robots on the power system. So quite a hefty involvement in the robotic industry. Thanks for that, Andrew. So over to you.
Kia ora all. Thank you for having me. Not as big as DK in terms of experience and things, only in the transmission space, but even so, not as much to compare. I'm wanting to share with you just where we're at and where we've been using robots. You'll be able to see some correlation with what's been presented so far, and you'll get a flavour for what's important to us. So I'll share my screen. And so are you seeing it yet?
No, it's not coming up, at least not for me.
Okay. Now, how about that?
Yep, that's better. Thanks.
Perfect. Right. So, our journey so far. Quick piece of context for you. So we're the owner and operator of the high voltage electricity transmission network here in New Zealand, and we run the power system in real time. It covers the country, 11,000 odd kilometres of line from the bottom of the south to the top of the north. Covers 173 substations, and all of those are unmanned. So those are all the wee little black dots that you can see on that map. And it's obviously connecting all the centres of generation, which are the major centres of generation, which are the grey dots, to the major load centres, which are all the blue dots. We have a HVDC link in addition to the AC network of about 1,400 megawatts capacity, and it runs from the bottom of the South Island to the bottom of the North Island. We have about 41,000 towers, 1,000 transformers and a couple of thousand circuit breakers for operating and inspecting. In terms of the New Zealand electricity power market, it's kind of similar to Australia. It's an open wholesale competitive market with anybody can be a generator, and the lines businesses that connect generation to towns and cities and then distribute around towns and cities are regulated entities. So Transpower is similar to Transgrid or PowerLink in Australia, and the distribution companies are similar to Energex, etc. in Australia. So why are we interested in robots, in this case substation robots? Fundamentally, it will always boil down to cost and improve service times. In the particular case that we were looking at, it's to do with response times and being able to detect faults earlier. We are looking further on than that immediate use case, and we're looking into the future of combining automatic inspections with AI. This is important because although there is lots of technology we can use, thermal cameras, acoustic sensors, etc., to detect the condition of equipment, it's not the equipment or the use of it, it's actually collecting that information, and that normally at the moment traditionally involves sending a man in a van to a remote site to do some work, collect the data and bring it back. If we could automate that process and then compare today's data to yesterday's data or a month ago's data and do that automatically, and only let us know when there's a difference or there is a trend that where a limit could be exceeded in a given time period, that would be really, really useful. There's a whole bunch of other applications that once you've justified the first one, you start to get that leveraged enhanced capabilities that you didn't even think there was value to be seen. For example, here is on-site construction supervision, or if there's design work going on at a site, that you can undertake more routine inspections as a virtual presence, just so that you can monitor construction, or during a design process you can go and double check a piece of information, the configuration of something that you thought you'd seen, or just to correct yourself just while you're in that design phase. So the power industry has been involved in robotics a long time. If you go back through the literature, it was back in the 80s, and the Japanese were leaders in this field, along with some parts of the United States. And the desire has always kind of outstripped what the technology could deliver, either physically, the physical capability, or from a cost perspective. We in Transpower have been hoping to be slightly forward thinking, and we've worked with TEPCO and others trying to get robotics into substations in a cost-effective manner, and we've been working with them on that technical working group. I've put a wee snapshot in there for you, so if you want some bedtime reading to see what the industry has been doing and for how long and what areas are of interest, it's worth a read. Pictures at the bottom are just the areas that we're most interested in, which is substation inspection, lines inspection, or doing some of the more dangerous tasks like bonding onto live plant and equipment, and trying to do that from a remote tele presence if we need to, or fully autonomously if the application allows. So when we're thinking about our needs, we really focused a value case on what's most important to us. Where do we get the biggest initial bang for our buck? And that was in remote inspection, either to call out or some form of routine inspection. If we can reduce the number of times somebody has to go to site to do those inspections but still complete them, we could get higher productivity and things. The image, of course, there is Spot. That's taken at our training facility. So we've tried various forms of robots, from wheeled to bipedal or quadrupeds, and they each have an application and space within a substation environment. And we'll show you what we've done and which direction we've gone. And this is kind of it. We started in 2013 with the thing on the far left, which was really fail fast and fail cheap. So that was, we teamed up with Massey University and we bought a kid's electric car, basically. Super Uber car, which we then started to automate because we just wanted to prove, could you do things in substations which are a high EMF environment. They've got their quirks, and everybody was saying we must do lots and lots of studies, we must spend lots on research, and Wi-Fi won't work, and many other things, and that was going to be a really big bill. And we decided we'd pop down to the Dick Smith store, buy a couple of standard Wi-Fi routers and bolt them in the substation and just see how it would work. And we thought that was a much more effective learning approach than trying to study it all first. We've gone through various iterations on the way, and we eventually got our two that look like Wally and Eve, as they are nicknamed in the top there. And the one we've kind of landed on is the one on the right-hand side. You'll see that they're all wheeled, and we can go into great conversations between quadrupeds and wheeled and static. But for our needs in the pure outdoor substation environment, long duration, not being able to be stolen, and a whole raft of other reasons, they are simple and cheap, and they hit all the key requirements that we need out of that task. Lots of testing and trialing, basically. Everything from EMF to traction to, just everything, user interfaces, and how will they be able to work out what parts of the site are easy to navigate around, what happens if the environment changes because we've got a bit of construction underway, or something's in your path or something. How do the Wi-Fi signals propagate through a yard? How much of it is to do with interference from GPS signals, etc. And that's why on the right-hand side, this is substation in Auckland, we had the routers set up here, and we decided to prove it through a high EMF environment, which is this is an SVC StatCom here with a bunch of transformers and capacitor banks, and this is a whole bunch of power transformers down here with firewalls in between them, so lots of things to shield signals. This is where we have our first deployment, which is Tuai. It's a substation. If you roughly know New Zealand, the North Island, centre of the North Island is Lake Taupo. Head off to the right, which sees the sun every day. First in the world is Gisborne, and this little piece down here is the Mahia Peninsula, where Rocket Lab sends a new rocket up into orbit, and this is Tuai Power Station and our associated substation. It's only 160 kilometres away to Napier, which is the major urban centre, population about 80,000 people in that part of the world. But the road's pretty gnarly, so it's 2.5 hours drive to get there. As I mentioned earlier, all of our substations are unmanned, so if we have a fault at a site, it's at least 3 hours before we have on-site presence. So to get that down anywhere close to our preferred 15-minute response time, we've had to traditionally pre-position staff much closer to the site, and that's had an annual cost of about $250,000. With the robot on site, everything for the robot's control was contained in the bag. We have a laptop, game controller, and a few other bits and bobs. We can achieve that 15-minute response time from wherever the go bag is for the robot. Just to give you an idea of the site itself, which is up in the hills, it's the penstocks for the power station. There is an overview camera, pan tilt zoom overview camera in the top of the crane building, so that gives us an initial big picture view of the site. And then the robot's dog box kennel is just down here, and we have Wi-Fi coverage within the yard from about 5 antennas, and it will be able to go either autonomously to a point through major routes, or it can be driven there manually, and we will be able to get response time in under 15 minutes. So these are some of the opportunities that we've kind of realized. It's been in service since 2020, and the top right picture is a gas gauge on a circuit breaker, and circuit breakers have an insulating gas in them, and if it leaks away, obviously we can't work the circuit breaker, but we do get an alarm to say that the breaker gas pressure is falling. To manage that and make sure that we've always got the circuit breaker available, we would obviously need to top it up, but making sure we know what's the rate of change and is it really an issue. Some way of finding that out would be great. So the robot every week or every few days, if it was a fast leak, has been driving out to Tuai, having a look at the gauge and because it's got a photo on it, we can see any particular change, and we've been managing the leak through that. And just remember, it's 2.5 hour drive up there, 2.5 hour drive back, all to read the position of the gauge. The other major thing that we've had is there was cable termination, a 33 kV cable with pothead, and that failed catastrophically. So we were able to put the robot in on a first inspection basis to inspect the failure. And more importantly, it's a place that if the equipment was under distress to do that sort of inspection, traditionally that's putting somebody into harm's way. But with the robot, we don't actually need to do that. This is a kind of a summary about how good the robot has been. So it's been deployed since March 2020. So, lockdowns meant that even traveling would have been a challenge if we'd had to manage the leaking circuit breaker and the catastrophic failure. So it really proved its worth. We can have all those value propositions beforehand written up in the business case, but everyone asks you the question of really? And right now that's really been proven. As I mentioned, it was always operated at least once every 2 weeks, and you can see that we have a couple of robots in our fleet. This is just kind of like monitoring the uptime and state of charge. It's been down for 22 days of 559, so it's had pretty good reliability. But of those 22 days, 20 were from our comms backhaul from the remote site, so they weren't actually the robot being down. They were actually in the comms backhaul piece, which is why we monitor which branch is actually down in the comms network. We screen grab here, that was an early generation driving tool. You get an overview of where you are in this at the site, a view from the driving cameras rather than the payload cameras, some controls, etc. In that particular application, this was just getting into position, and then we'll go full screen with this kind of what's happening from the payload camera. And people were having a project at the site, and they needed to do an initial site visit and then follow up construction visits. And obviously, it's a remote location. People traveling from Auckland and from Wellington, we had air travel and driving, etc. for numbers of people. Well, we could conduct those site visits from your office using Teams to get MS Teams streamed live from the robot to be able to give you that overview of the site and understand what's going on and everything. So that if you did need to go to site, it could be a much more focused visit. Or if you'd been to site and you were just struggling to remember just how it was actually configured, because you know what it's like, you don't actually take a photo of everything you thought you did. That was a very good way of cross-checking that. So there we are, robot in the yard. Sometimes it's hot and dry. In this case, it was obviously wet and muddy there. And one other application we've found is because it's a remote site, when people go to work there, this is an operator in his overalls there, going to do some task on site, we send the robot out as Overwatch for that person as well. Some of the features that are on the robot, that we have a mic and speaker, so somebody back in the office can hold a conversation with somebody on site. So having them there in an Overwatch function, they're 2.5 hours away from help if anything goes wrong, but knowing that the person hasn't got into trouble, that everything is safe and well, has actually been a health and safety mitigation instead of having to have double manning. So it's been quite good. Just another little picture of just the robot in the doghouse. Self-autonomous parking and battery charging and everything else. It's really a lightweight structure just to keep the direct rain off. The robot's built to a IP68 certification, just so that we could leave it outside in the rain. And it's actually parks out next to equipment that might be under distress. So if we were having issues with a bushing that was running hot, we can actually park the robot out there, turn the camera to watch, put it on thermal mode, and just monitor what's going on in terms of temperature, and people aren't so worried. That is one of the major attractions for a wheeled robot in a substation environment. If you don't need to climb stairs, etc., is you get a much longer on-site duration, and you could have something much smaller, but that's got its challenges with people possibly nicking it or other environmental issues. But with something that's quite large, we've got a lot of capability to add additional payload to the robot. And more importantly, we have almost 8 hours of endurance on here. So we can actually arrive and in terms of operational time. But if we're parked up, we could stay parked up monitoring something as long as we weren't moving for just over 24 hours. So that gives us a lot of capability in terms of if something goes wrong and we need to monitor it and nurse it through the next little while people get to site, we've got the capability with the robot to do that. We can listen to things to see if things are making noises. We can see things visually, and we can see things in the infrared. But what's the prize? So when we were doing this, this was the initial prize. Remember, it was all about the routine inspection and fault response, getting fault response at our really remote sites to under 15 minutes. We now have to have Manapuri up into the red. I haven't updated that slide just at the moment because it's just been recently announced that it will be completely unmanned. Even the power station generation staff won't be on site for most of the day, and definitely for the whole period over the weekends. So the value has just gone right up at the moment. Those are just the easy direct costs that you can point to get those benefits for the business case. On top of that is everything else that we were just talking about, things like overwatch for people or being able to pull out some more of those routine inspections, etc. So there's a bunch of future opportunities that we were looking at that we can do with the robot, which normally means adding a whole bunch of extra payload to things. The last one, the remote switching, it's a really fascinating piece. So you can imagine when we take a circuit out of service, we open up circuit breakers at either end, we close the earth switches on to isolate the line down, we open up disconnectors. You can do all that with push buttons, that is fine, you can automate that. But for the people who are on the line, who are undertaking work, they normally like to have confirmation that those things have actually happened. The way that happens at the moment is they directly speak to the person on site who's unlocked the switches and moved them into different positions, and they feel very confident about that. If we do it all completely remotely and automatically, they don't feel quite so comfy, and you can kind of appreciate that. You don't want somebody in the control center accidentally pressing close and livening the circuit back up again. So we've built an interlock system, and part of that interlock system is to be able to give assurance to the people in the middle of the line. We can provide them with a real-time picture of the device in its position, because we can dispatch the robot to sit there, watch it, and take a picture for them, and that gets emailed back to them, and they have a lot more confidence too that everything is as it should be and continue with their work. So remote switching is again another large cost saving and time saving of operational staff time. So other things, robots and drones. The reason I thought I'd touch on this is it ties up quite nicely with what Daike was saying about tower painting or inspection of towers. So those were some of the things that we were most interested in, and conductor inspection. We have 11,000 kilometers of line. It's a 3-phase network. Most of the lines are duplicated, etc. So there's many hundreds of thousands of meters of conductor in the sky, and it's obviously installed over different periods of time. And bad bits, like the picture that you see from a bit of corrosion in the bottom right hand corner, do occur, but they only make up a small fraction of the total length of conductor that are in the air. And you don't want to have to replace everything based on age rather than condition, because it's just completely inefficient and very expensive. So we'd originally started work looking at line crawling robot to be able to crawl along the line, because we thought, we needed good imagery of the conductor and its state to be able to do that sort of work. And at the time, 20 years ago, people first started at this, and we got into it in 2013. So it's almost 10 years ago. That was certainly true, because you needed to stand off so far. Today, we're doing it with a drone. We fly beyond. We do extended line of sight, and we've just got into beyond line of sight. We're pushing to go up to 20 kilometers. So we're currently able to do 7 on extended line of sight. We're pushing to get up to 20. It's an electric helicopter drone. And the real game changer is in the imaging. So the pictures that you saw on the slide here are taken using this drone. It flies approximately 10 meters to the side of the transmission line and is flying at the same height as the top crossarm. So if it's a 220 tower, then the phase spacing, or the distance between crossarms, is about 10 meters. So if you're thinking about a hypotenuse line of sight, you're having to have a camera that will produce the images that you can kind of see in the bottom right corner. It's producing that from about 30 meters away on the diagonal to the bottom conductor. We managed to pick up all 3 conductors to the same kind of resolution, because camera imagery has improved to the point that it's small, it's lightweight, it's pretty cost effective, and you can get great performance from depth of field and focal length, etc., to enable you to capture really efficiently. So we'll fly down one side and we'll fly back up the other. So in terms of conductors and the towers themselves, overall we'll be doing it from drones rather than actual specific climbing robots. However, we're also using drones. We were going to use the line crawling robot to be able to test the joints. So conductor, the wires come on drums, are about 3 kilometers long, and obviously you have to connect them together. So we have these joints that connect, these compression joints that hold these conductors together. And at the moment we use human suspended cargo to use a ductor, what we call, to measure the resistance of the joints and make sure the sleeves have been centered within those joints. And we're checking for degradation. That's obviously A, expensive, and B, relatively dangerous, and C, it's really hard to get to the center phase. So we're building a drone and working with some people both in New Zealand and in the US to take our standard conductor insulating measuring device and to bolt it to a drone and get it located to land onto the joint. Because the biggest challenge was being able to get it on, measure all 3 or 6 that are within that span, and then move further down 3 kilometers away and repeat the exercise, and trying to do that efficiently. We found that line crawling type devices were just you had to get it up there, and then it was just too slow. A drone approach was the way to go. We were also using robots and considering how we would use them, either to look at the gantries and other structures within a substation. Again, we've found just the amount of ground we can cover in the imagery we can get, the ability of using RTK and a bunch of visual positioning software, meaning that we're immune to EMF interference and issues with GPS interference. We get some excellent imagery. These are all the zoomed out pictures. I was trying to show you just how far away we are from the structures, but we can zoom right in and see individual bolts out of these pictures. And we can do that just because the quality of the imaging these days is so great that you you collect such a high quality image that we can be 5 or so meters away, but zoom right into the individual bolt head and read the engraved name on top of the bolt. So we are currently doing all of our substation inspection for gantries and towers and anything above walking height, using mini drones, and anything, however, on the ground we'll be doing from a robot. But there's still a place for robots, and this is the real application that we're interested in with and Daike's presentation really covered it well with the climbing robot with TEPCO. So towers, they're all galvanized, but after 40 years, the galvanizing starts to go, and you either replace the tower or you have to paint it to keep it in good nick. It's currently a manual operation, as he highlighted, and there's just a lot of odd angles to paint. Apart from the blasting side of things, which is either water blasting or garnet blasting, or brushes, wire brushes, which is for prep. There's then putting the paint back onto the tower, and you can see that that's what's happening in all of these pictures, right? It's all roll it on, and it's all people up towers. Regardless of all of that, the real money equation at the moment is the top right corner picture, where you see the guys up the tower and the two pieces circled in red. We can paint the whole tower, we can paint most of the cross arms, but it's the piece right out at the ends, the cross arm tips, where they phase to earth. So it's from the bottom of the insulator up onto the cross arm, or from the bottom of the insulator and conductor to the cross arm below it. That phase to earth clearance is just a killer. So the minimum approach distance in there. So we cannot paint these tips with this circuit live. Now, you could just say, well, turn it off. And we can, but it does mean that all the powers are going up the other side. So if in our part of a world there is only one line but two circuits, then that means that the load is being supplied just through one circuit. So there's a risk of non-supply. So we try and do as much of this live as possible to minimize impacts to system availability. So having Daike's robot climb up here all by itself and then get out onto the ends, and then be able to just do the cross arms or the cross arm tips where it can stay away from being inside of MAD, the minimum approach distance, and then prep and paint that would be fantastic. And then being able to have, say, 4 of them working on a tower, so that we don't need to put 4 guys up a tower, would be even better. It'd be great if they were able to just support the robots from down below and fill up the paint buckets or whatever else it is that they're doing. That would be really, really useful. And that brings me to the end of my presentation. So I'll stop sharing there and happy to take any questions.
Thanks, Andrew. Thanks very much. That was, well, I found it very insightful because it's not my area, and I really appreciate that. Definitely a lot of thought for future ideas. I guess Daike was keeping his ears very clear to understand some of these, which he will obviously know better than anybody else. I'm opening the floor for questions. If anybody has got any questions, you're welcome to raise your hand or directly ask the questions. I do have one, so I might start on this one since there are no takers. On the robot, on the rover that you have on site, have you considered adding some sort of manipulation to be able to do more than just visualize things on site, potentially operate? You mentioned this gas that needs to be filled up, and I guess that's something that could be done. Or that type of environments. Have you done any manipulation that you could do?
So we have considered whether or not we would put a manipulator on it. For the time being, the answer is no, but the platform is big enough to be able to take that that type of thing. It really comes down to the business case and where is the value. The value has been in the inspection and everything else. Surprisingly, some of the other value is not in being able to manipulate or work in your environment. In our cases, it's actually having some of the tasks done. So one task in a substation, like a railway line, is where you have a metalled switchyard, one with crushed rock in it. You need to spray the weeds every 6 or 8 weeks. So having the robot fitted with a spray tank on the back of it, so as it's driving around every now and then it can spray the weeds, is actually a much more useful business case than having a manipulator on it to be able to press buttons or something, because that means we just don't need to send a person out to site to spray the weeds. It does mean you've got to have a certain sized robot, because otherwise you're just going to send a person out to site to fill up a really tiny weed spraying tank on a really tiny robot. So it's actually having size actually helps the business case efficiency.
I'll just follow it. I know that there's 2 takers here, but I'll abuse my position as a host. Have you compared I saw you have the Spot in there too, which could be doing some of this work that you just mentioned. Very good cameras in there too. Have you put them side by side, so to speak, in terms of the advantages or the disadvantages of one versus your own design?
Yep. So the advantage for Spot primarily is it's a system that's off the shelf. You can go and buy that. Its other major advantage is that you can walk upstairs, which a wheeled robot can't. Its disadvantages are it's very expensive in comparison. It doesn't have the endurance as much. It doesn't have as big a payload capability as what the wheeled robot does. So for example, we couldn't bolt we couldn't have all the camera imaging things on Spot plus have weed spraying on Spot, right? It's one or the other, so it's not as flexible that way. You'd have to go to a much bigger dog, whatever they're going to call that. The other item is because it's a quadruped, everything's out of balance. So dynamically, it's always keeping itself balanced and stable. So in those long duration ones where we have a power transformer, where we're trying to monitor the bushing for it and then occasionally drive around it because it might be a hotspot, we get a much longer duration and time on scene with a wheeled robot because it's dynamically stable and the only power it's drawing is what's coming through the camera as such. So we don't have to return to base for charging as much. And then finally, there's the theft and other type factor, right? Spot is between, you could probably carry it with one person, at least drag them, but it's quite easy to nick. Once you break inside the station, you can take Spot away. You can do all sorts of stuff with alarming and GPS, but the desire to pinch one is just too great, whereas a normal bigger wheeled robot is just somehow not quite as cool, and therefore there's less threat of it being stolen.
Yeah, I agree with that. It actually had a bigger brother, which is the one that originated this idea. I don't know that it's actually for sale. That one won't have any issues with the payload, but certainly battery life, yeah, it's pretty amazing. Okay, we have 2 takers here also. I'll start with John. I don't know who raised their hands first, but John, please go ahead.
Thanks, Andrew, for the fantastic application area. So I saw the cross-tip painting problem. I think it can be a perfect application of drone-based painting. So have you considered that? So maybe you can use some tested line connection to minimize the payload issue. So we can provide the power from the ground, and then you can climb up and then do some aerial painting. What do you think?
Anything is on the table for painting towers, right? Particularly the cross arms. It's I'm sure, however we do it would be good. Just anything is on the table, right? There is no stupid suggestion or anything at the moment, because the only option we have today is send a person up there with a wire brush or a spray gun, a paint roller, blasting. That's the only thing we've got. So I'd be more than happy to take other people's advice and give anything a try, basically.
Mm-hmm.
Do you have any other questions, John?
No, that's all. Yeah, maybe we can have a further chat on the idea.
Love to.
Yeah. Okay, Richard, please go ahead.
Yeah, hi, Andrew, thanks very much. Interesting presentation. I made the comment in the chat that it was great to see a business case. And because from my experience, getting proof of the value to the customer is one of the challenges with a lot of research projects. So I'd be interested if you could share with us how you went about getting support, whether it was you or someone else went about getting support for this journey that you embarked on, and how you built up the business case progressively for obviously increasing investments of time and money to go through these various iterations, and any lessons learned that you'd like to share with everyone else, because this challenge faces everyone who's doing new product development, particularly in the industrial robotics space.
Well, challenge is the right word. So, you've got that great expectations, pit of despair, and great big money pit the thing turns into. We did a number of things. The first was look at those use cases that were the most important to us, first of all, and where we were spending lots of money. And a lot of that was trying to contain everyone's enthusiasm. It says, look, I could do this with a robot. Wouldn't that be great? To going, all right, before we get too caught up with the cool tech, where are we spending our money now? So that basically meant lots of hours of going through invoices in one form or other, going, well, how much do we spend on that? And what about when we go to take an outage, and how much time is people spending on accommodation and stuff? And it was just lots of, shoe leather footwork that we had to do for a start. Find out where we spend our money now. And then of where we're spending our money, what are the sites where we're spending it the most? And that's where we rattled down to that. We have 173, but we really rattled down to about a half dozen sites where we're really spending our money. And then once we'd done that, it was a case of saying, well, how much do we think it might actually cost us to develop? And that's when we were originally looking at things like Spot and anybody else's robots who were out there. You find out how expensive these things actually are, and going, well, it's just not worth it. And that also focuses your mind on some of the ways that you can deliver some of the benefits. So, wheeled over anything really cool and sexy, because it's much simpler and cheaper and other things like that. So you had to focus on where you're spending your cash now. What are those tasks that are consuming the majority of that cash? And then looking at it from a perspective of what's the minimum I can get away with to deliver that equivalent service? So that's like that minimum viable product thing. And how, once I've got those key features built in, how do I take it on from there? That then leads to who are you going to work with, right? So once we'd worked out what the value was and what were the features we were looking for, it was then saying to people, who can we work with if we gave them a pool of cash which is worth about this much to us? Because we wanted to say, if we could get a return on investment in like 5 years, because that's our revenue control period, our regulatory control period, how much to get one of these things stood up? So that's when we started working with educational institutes like various universities or other research labs, your CSIRO or whoever it happens to be, and saying, look, we can front this amount of cash. Is anybody interested in robots? If we gave you this amount of money, you're prepared to throw your research time or students at it on the other side, because I think that's one thing which we all had to manage our expectations of. If we wanted to make lots of progress, lots of money had to go in fast if you wanted to do it in a really short period of time. But if you were prepared to take a longer period of time, then you could do it by working more at the university's pace, so that they would always have students coming through and they could. But we did work with them to parcel the research up into multiple little projects, so they would run 4 or 5 things in parallel rather than one project. They'd run 4 or 5 little projects in parallel. They would all feed into one, and we'd get something out at the end of it. So we kind of were working quite collaboratively with Massey. So that was how we kind of made a lot of progress. Find somebody who was prepared to chuck a lot of students at it by carving things up into lots of little projects, and then we could just give them a chunk of change and they would go away and do it. And we were able to get to numbers of iterations through from both mechanical, electrical, navigation, software, you name it. They had lots of little student projects, and that's kind of where we got to today. And we're saving money at 2i, right? There's no two ways about it. We're saving money at 2i, and we're just running through at the moment, revalidating our new business cases for are we going to lease another 3 or 4 of these things? And that's another thing that businesses need to take their mind of. They have a need to solve information. They want to make a decision about something, so they need information about that, which means they need data. How you go about collecting the data? Do you really need to own the robots? Like, they're cool to own, don't make no mistake, but do you really need to own it, or could we lease that as a service from somebody? And that's where we're kind of leasing the robot from Massey. We have a couple in the fleet now, and we're contemplating that we'll add another 3. So that's where we're at. I hope that answers all your questions.
Thank you. That answered, I guess, my question, which was how you got through, how you got the support, how you engaged, and it also demonstrates that you were very forward-thinking because you started the planning process well before you started engaging with any universities.
Yeah. It's about the size of it. Yeah.
Thanks, Richard. Do you have any other questions? Probably not. I actually thought it was very insightful to learn of this step-by-step approach, because you're right, we tend not to do it that way. We actually tend to have a big upfront scheme where we want to have this continuing grant for a few years. I was actually curious to see at what level of engagement with the university, Massey University, you actually have this going on. Like at the, you have like I don't know, a couple of PhD students being thrown at this problem, or it's more like a bunch of honor students kind of producing some of the outcomes?
So the person to speak to is Johan Pottinger. We've had a relationship for 6-7 years now. So it's provided him with a stream of students to be able to work on things. In terms of the types of students, there's been, when I say normal students, masters and PhDs, depending on what the problem is that they've needed to work on. They've been able to apply a suitable student to the suitable problem or problems, and probably get most value out of it that way.
And you also mentioned, I'm hogging this, so anybody wants to throw another question, please just go ahead. I'm just quite excited to hear this. You mentioned that you're leasing these units from them, meaning that they obviously have got a contract that supplies the maintenance, I would say, basically, or at least guarantees the maintenance of the unit. That's how you operate, right?
That's completely true.
Yeah.
Yep.
And,
completely
yeah,
true.
okay. And you have them for X number of years. Make sure that happens. Okay. All right. Yeah. Yep. Interesting. Anybody else? I feel like I'm hogging this. Definitely. I see you're ready. Okay.
Yeah, so thank you very much, Andrew. This is very interesting talk. So you mentioned the collaboration with Massey University, and is that true? You have a big engineering team in Transpower in New Zealand, and then you just only get support or help from the university more related to what you cannot do. Is that true or not?
A big engineering team. So Transpower outsources all of its engineering, detailed design and engineering. So in terms of what we do, we've got a lot of asset management and technical expertise about transmission lines and substations and DC cables and a whole bunch of power electronics. So we know a lot about our stuff. but we don't do the detailed design work in-house. So looking after all of our assets, we've got a engineering team in total. So it's the operational engineers who respond to faults in real time and love and buff and care for things. And then the people in the grid development side who are planning the future substations and transmission lines. We've got a team in total of 65 engineers. Everybody else, like all the detailed design work for a new substation, is done by contractors and consultants. So think of people like Becker's and AECOM, Oricon, Jacobs, etc. They do all of our detailed design work. All of our maintenance work is done by contracted out to service providers. So yes, we have a reasonable sized engineering team, but they are focused on understanding the assets, understanding their conditions, their condition and failure modes and health, and options to replace them or augment them. But the actual detailed work, once we've decided to build something or change something, is all contracted out. So that's very similar to the robot in effect. We kind of know what we want to do, and we've worked out how much it's worth to us and what things are of value to us. But everything to do with the robot is handled by Massey. And even the driving of the robot, we had a really interesting initial vision that the control center staff, if something went wrong, it was the control center staff who would go and get the robot to site, tell the robot, go somewhere and have a look. In reality, we've changed from that. We've changed that to our service provider, who would normally drive out there in the van. They're now driving the robot instead. So even the day-to-day operation of the robot is contracted out for the actual fault response or something. So yeah.
Thank you.
Very interesting. Do we have any more questions? We're coming down to the end of the talk. In any case, I think everybody would agree that it's been very, very exciting to hear. I'd like to, unless there's any other takers, I'd like to thank both Dika and Andrew for their very interesting business-oriented developments. Very, very interested in everything that is happening in that space. And yeah, pretty much invite everybody to join us next week, which is on Thursday, again at 11. It's at 11, Dika, or 12? I don't remember, 11.
Yeah, 12 for the, 12.
12, right? For our final chat on this topic, where we're going to have various business and academics participating in an open panel to discuss pretty much a wrap up of what we've been learning over the last 3 weeks. Yeah, Dika, unless you want to add anything else, I'll just thank you and Andrew again and invite everybody to join us.
Thank you very much. Particularly thanks Andrew and Richard, and it's very nice to see you here. Yeah, thank you.
Thanks for having us. It's been good.
Okay.
Okay, thank you. See you next week.
Thanks, everybody. All right, hope to see you all next week. Cheers.